So let me start with this question. Uh, there's a general impression. Some people might say it's right, some people might say it's wrong. That's a general impression anyway, that easy simulation, CAD designer friendly simulation means it's less precise and less accurate. So, Omar, I'm going to have you discuss this point. What do you think? Do these type of simulations need to come with a warning label that says there are limitations?
Well, I mean, look, I don't think so. And I think that the days where you could kind of decouple design from simulation are, like I said, they're just over. And even if you're just doing preliminary simulation to kind of weed out poor designs, I think that's fine. Like there's still a lot that you could, there's still a lot of basic simulation that you can do, linear static, frequency analysis, thermal, that you can have designers do. And I still think there is going to be a place for analysts to sit. But this discussion specifically about whether or not there should be simulation embedded or just easy to use tools for designers, no, I don't. I think there should be, and I don't think you suffer from a reduction of accuracy just because you have tools that are kind of more geared towards designers. And if you just look at the now what we're offering on the 3D Experience platform is basically SolidWorks CAD utilizing the Abacus solver. And if anybody wants to argue about accuracy, I would take the Abacus solver over a lot of other ones, most other ones, all other ones, basically, in the structural realm. Definitely, for sure.
Julian, previously, I noticed when I said previously, probably about 10 years ago, people accept the fact that simulation takes a lot of time. So I remember engineers talking about hitting run and going to have lunch, or sometimes time it in such a way so that they can hit run and then go back home and then come back over the weekend to collect the responses. Have people's attitude towards how fast simulations should work, has that attitude changed over time?
Yes, user attitude and expectation have changed significantly. You can see your children, for instance, they don't play with the same game that we did. And so, yes, people has changed, and we can see, and we can see some example like the movie here. That's CFD computation, a flow computation with several GPU used and so on. Imagine make this type of picture and animation with such level of reality 20 years ago. It's impossible. So I think now we are the age of the maturity where the numerical method, all the technology used for the simulation has been improved. And so we can provide very modern simulation using also new CPU, GPU technology in order to provide close to real-time feedback. And I think it's very important for such designer solution. A designer design a component in a real time. He make an operation, he gets the result. Today we have the possibility to bring the same level of interactivity with simulation.
For now, let's also talk about another topic that has been making a lot of headline, and that's ChatGPT. ChatGPT makes it possible for people to interact with softwares in a natural language. Currently, you can't really talk to it. You can have to do it with text. But I wonder if people does that kind of idea of natural language, does that evolve? How might that evolve simulation UI? Is it going to make it easier for us in the future to actually use simulation, so even a broader range of people who are not simulation experts and PhD, like Omar, would be able to use it? So Omar, Mr. PhD, would you answer that?
Yeah, sure. So, I think we're kind of in the infancy of understanding exactly where things like Chat GPT and, those types of programs can take simulation. I will say that there have been discussions internally here at the that to try to figure out if there are ways that we can leverage that technology to help, new users or new people into the simulation space get up to speed and kind of understand best practices. And I would say right now it's too early to tell, but I wouldn't be surprised if in a handful of years you see people really leveraging ChatGPT or those types of programs to figure out best settings, best turbulent models to use for CFD analysis, or best EMAG settings, mesh settings, to ensure that they're using industry practices to solve their analysis, right? Because it's a garbage in, garbage out. I know there was a question earlier about the accuracy for designers, right? It's hard to answer that because you still have to generate a mesh, you still have to put on your boundary conditions, understand materials. So if you don't have a good understanding of those types of things, the results that you get are going to be poor. So I could see ChatGPT definitely pushing people in the right direction for analysis.
I think everybody try AI first. So we have tried also. The objective of AI for Siemens is to improve the productivity. The first idea that we have with AI, and that's already available, it's generative design. Generate a shape for additive manufacturing, for instance, or for overusage, generate automatically a shape. Now, in terms of performance predictor, have you asked me the question? Yes, we are trying several things. The main idea is to provide advisor, someone to help you in order to set up your simulation easily, or to solve it, to help you to interpret the result, or help you to improve the design that you have currently in front of you, but you need to correct to minimize the stress, for instance. So yes, AI is in the daily conversation. The world is evolving in this direction.
Does democratizing simulation assumes that there's no human interpretation of the results? Is that a go or no go decision, or more a gray area that requires a more human driven analysis? What's the target user base of simulation, easy simulations? Omar?
Well, I mean, I don't think I can't see a time, and maybe that's because I worry about my own future, where interpreting results by a human isn't going to be important, right? I do think, look, the less human interaction that you can have, whether it's entering material properties or, coming up with templates for analyses that you do, like the less human interaction that you can have on the front end, on the input side, I think that is really powerful, and I could definitely see some benefit from that. But look, I think you're always going to have a human at the back end that's interpreting results and just making sure you don't have a garbage in, garbage out kind of situation. Right now, that doesn't mean that you're not going to set up sensors or certain ways of post processing that flag issues, right? Whether it's like a natural frequency that's problematic, or a temperature, or a stress, or a displacement, factor of safety, whatever. I think there are certainly ways that you can create flags for the human to look at, but I think it'll be a long time before we sunset humans post-processing, or looking at post-processing results, right?
Post-processing, it's the most important stage in this process. It's the most important stage. Doesn't mean that we will just check a value on something. This one, I think, can be fully automatized to check, for instance, result of a test and compare the result. But we see some trends in virtual reality, for instance, to integrate directly the simulation of the simulation result in the reality picture, and to see how it's behave, analyze the result, analyze the system complexity in such way to help it. And that, I think, this goal will be always done by a human. We can see to use the result for an engineering purpose, but we see more and more users using CAE result for marketing purpose, for instance. So I think a human will ever post-process simulation data.